Hello everyone, here is a question based on electrochemistry. 4 different conversion reactions are given in list 1 which we need to match with the number of Faradays required in list 2. We know that 1 Faraday is equal to charge of 1 mole of electrons. The actual value is approximately 96,500 coulomb per mole. Here we don't have to worry about the actual value. We need to figure out how many moles of electrons are required for each conversion reaction. The first reaction given is 1 mole of H2O to O2. The stoichiometry here is not specified. 1 mole of H2O would actually give half a mole of O2 and 1 mole of H2. The stoichiometry is specifically mentioned for the water, and therefore we need to figure out for 1 mole of water what is the charge required. This is half a mole, this is 1 mole. If we have 2 moles of water, you would get 1 mole of O2 and 2 moles of H2. In presence of an acid, the half reactions happening are as follows. At the cathode, reduction will be happening. If you have 2 H plus ions, then we get H2 gas. At the anode, oxidation will be happening. So, if we have 1 mole of water, that would give half a mole of O2 and 2 H plus, and the charge required is 2 moles of electron. That means 2 Faraday. If we are calculating as 4 Faraday, keep it in mind that you are calculating that value for 2 moles of water. For 1 mole of water, the charge required is 2 moles of electrons, and therefore 2F is the correct choice here. In the next case, 1 mole of MnO4 minus 2 Mn2 plus. This is a reduction reaction. Permanganate ion is getting reduced to Mn2 plus. Keep it in mind that increase in oxidation number is oxidation, decrease in oxidation number is reduction. This is obviously a reduction reaction, because if we put minus 2 for each oxygen, then this will be minus 8 and this will be plus 7. So, plus 7 is becoming plus 2. That means this is a reduction reaction, and we need 5 moles of electrons. That means 5 Faraday. Therefore, B matches with 4. A matches with 2, B matches with 4. The only option where we see that result is option 1. Therefore, C should actually be 3 Faraday. Let us cross check that. This is another reduction reaction. If you have calcium 2 plus, gains 2 electrons and becomes calcium. So, we have 1 mole here, 2 mole here, 1 mole here. But the question is for 1.5 mole of calcium 2 plus. And therefore, 2 times 1.5, and that will be equal to 3. That means 3 Faraday. And then in option 4, ferrous oxide is becoming ferric oxide. That is an oxidation reaction, because here it is plus 2, here it is plus 3. That requires only 1 mole of electrons. Therefore, C matches with 1 and D matches with 3. Therefore, the correct choice is option 1 here.